Alright, we're going to be on statistics 2 days, today and tomorrow. Not tomorrow, Monday. Today is going to be the probability side of it, and then Monday will be the statistics side of it. So all probability is the calculated likelihood that something's going to happen. How many people played Life as a kid? All that is the probability something. So if you think about, if you remember the game of Life, you had that road that was real risky and you had the road that was a little easier to get down. You calculated it kind of in your head which way you wanted to go without even knowing. Who wanted a car full of babies in their car playing Life? What? You know what? And then the weather is probability. That's the whole thing. So if you like probability, you probably should become a weatherman or weatherwoman. That's their whole job. That's all the weather is. So tomorrow there's an 80% chance of rain. That's the probability it's going to rain. There's a 20% chance they're going to be wrong, and it's okay. That's part of their job. So different methods for determining probability. Empirical, and so that's actually doing an observation. So rolling or flipping a coin. And then theoretical, this is what it should have happened. So now let me go back up here. So in empirical, I flipped a coin and I got heads 7 out of 10 times. So I had 70% of my flips were heads. In theory though, what percent of time should I have gotten heads? 50. So that's the difference between the two. And then we have subjective, and that's where you're like, I think this is what's going to happen. If you ever, and I highly recommend take prob and stats either in high school or college. It's one of my favorite classes I ever took. You would get into subjectives. Did y'all get into it a little? It's more like this is what I think is going to happen. We're only going to do an hour and a half of probability, so we just don't have time to get there. So the experiment is actually what you're doing. So flipping the coin would be the experiment. And then sample states, what are the outcomes that could happen? So if I flip a coin, what are the outcomes? Heads or tails? Or tails or heads?
Or side.
If you get a side, you got to just stop right there and go buy a lottery ticket. And then the event, I'm going to show you in a second. It's easier to show than an event's a subset of the sample space. We'll see what happens in a minute. It's easier. And then the outcome is what happened based on this experiment. So what was the outcome of flipping that coin? That's what it was. So now you see why I gave you the Quizlet with all those terms on it. There's a whole lot of terms that go into probability and stats. So let's look at an example. What's the probability of a tossed coin landing heads up? So what's the experiment? Tossing the coin. And obviously I know you could do this in your head, but the sample space, they're going to use a probability tree, and we'll see a couple examples with the probability tree, and then I'm okay if you never do one of these in here, but for especially visual people, these are helpful. So sample space, I can get either a heads or a tails. And then the event, I told you I'd show you, the event we're looking for is a heads. And then the outcome, oh, we got a heads. So that's kind of the different steps of it laid out. And so probability is just communication. The communication of a belief that something's going to actually happen. And so probability is expressed as a number between 0 and 1. So the probability of flipping a heads is 0.5, but we oftentimes will think 50%, but technically it's 0.5. And the total probability of all the outcomes should equal 1. So you have 0.5 of getting a heads, 0.5 of getting the tails, add them together is 1. On the quiz next week, if you give it to me in decimal or percentage, I don't care either way. Your stats teacher might be a little bit more picky, but relative frequency is, I gave you all of this. But the formula, f of x equals n of x over n. The n of x is how many times did it happen, and the n at the bottom is how many times did you do the experiment. On the formula sheet, all of the formulas for probability and statistics, the very front page. The top box is stats, the bottom box is probability. And I'll tell you when we get to, in a minute, I'll tell you if there's a little difference on the formula sheet. So example, what's the probability of a tossed coin landing heads up? They're going to show you a probability tree. For this one, I don't think you need it, but you can either flip a heads or a tails. So how many desirable outcomes are there? What do we want? A head. So how many times can we roll a head? One time. And how many possible outcomes were there? Two. And so then you plug it in. F of x is 1, because that was the desired outcomes, over possible outcomes. So 1 over 2, or 0.5, or 50%. So obviously this one you could do it in your head. You probably wouldn't do all of this to get this. So what's the probability of a coin landing tails up? 50%. Because they're going to add both up to 1. So what's the probability of tossing a coin twice and we want it to land heads both times? So probability tree, we're going to flip it one time and we can either get a heads or a tails. And then each time from there, we're going to flip it again. So if we flip a heads first time, we're going to flip it again. And from there, we can either get a heads or a tails. And we hit tails, we can either get a heads or a tail. So how many desirable outcomes are there? One. And we got that by heads, because that's what we're looking for. And then how many possible outcomes were there?
6.
4.
4. 1, 2, 3, 4. So we plug that in, 1 over 4, or you have a 25% chance of rolling 2 heads back to back. So if you have a friend that comes and wants to bet you and say that they can do this, I'm not telling you to gamble, but it's a good bet to take. You have a higher chance of winning than they do. You saying they use a fair coin, they haven't weighted anything down. But I'm not telling you to gamble. What is the probability of tossing a coin 3 times and it landing heads up exactly 2 times? On this one, I am going to use a probability tree, but we're going to see this problem again and how to solve it mathematically. So we flip it one time. You can either get heads or tails, same way, just like the last time, either heads or tails, heads or tails. And then each one of those times then is going to break out to a heads or tails. So we just want heads 2 of the 3 times. It doesn't matter what order, we don't care, we just want it twice. So heads, 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 doesn't work. Head, head, tail, there's 1. Head, tails, heads, there's 2. Heads, tails, tails, no. Tails, head, head, yep. Tails, head, tail, no. Tail, tail, well, I already know it's not going to work. So how many desirable outcomes did I have?
3.
I'm just going to highlight it for you. How many possible outcomes were there? 8. So then you plug it in, 3 of 8. Or you have a 37.5% chance of flipping heads twice. So you actually have a higher probability of this happening than rolling heads back to back. So if that same friend wants you to bet on this, probability is still in your favor, it's just not as in favor. We'll come back to this problem. So binomial process, all that means is that the trial outcomes don't have a bearing on each other. So if I flip a coin, if it lands heads this time, that heads doesn't make the next one, it's not skewed in any way. They're all separate of each other. Just said everything. Thank you. So Bernoulli, you remember this guy from anywhere?
Yes.
Heard of him?
Yes.
What's he do? This guy did a lot of stuff in wind and airplanes, and
Didn't they talk about it at MIT?
they did talk about it. So the way the wind goes over an airfoil or the wing of an airplane, this guy was pretty smart. So he came up with the process or the mathematical way of solving the probability. So I told you on the formula sheet, their variables are a little different. It is the same thing. The variables are just different on the formula sheet than this. I don't know why. Capital P stands for probability. X is the number of times an outcome is going to happen. And I'm just going to go through these and then we're going to see it happen. N is the number of trials. How many times did you do it? Lowercase p, the probability of success on a single try. So let's say we're going to flip a coin 100 times and we want to land on heads 40 times. What's the probability of success on a single trial? What's the probability we can get a head? 50, that's what that is. And so then the probability of failure on a single trial for a coin is going to be 50. And then your exclamation point or factorial. Everybody in here has done factorials. Yeah? No. Okay, good. We'll go over them. So factorials. They're super easy in here too. So 5 factorial, what this means is 5 times 4 times 3 times 2 times 1.
Oh, okay. If you're dividing it, you just like cross out the...
We're not doing all that, don't think about it. This is all we care about. Most calculators can put this in there. However, if you forget your calculator and you have to use my favorite calculator of all time that does not have a factorial button, you just got to know what that means. Alright, so I told you this problem was coming back. What's the probability of tossing a coin 3 times and it landing heads up 2 times? We're going to look at it again, but we're going to look at it mathematically and not using a probability. Alex, you can just put it on the counter there. Thank you so much. Alright, so there's my formula. I'm going to show you up here, and then I'm also going to show you over here, because on here, I lay out the factorials, but then I'm going to show you what it looks like with the exclamation point not spelled out so much. Alright, so it says P of 2 because 2 is how many times I want to hit heads. So that's the probability of 2 times. In factorial, y is in 3. Number of trials. That's how many times I'm going to flip it. So another way this looks is going to be 3 factorial. What is P again? success on one try. So what? 50. I have a 50% chance of getting ahead, right?
Yes.
So it's 0.5. And then what's X again? Number of times. How many times do I want to hit heads?
3. Oh.
2 times. So in this case, it's going to be 0.5 squared. But just know that this number could, let's say I flipped the coin 200 times and I want to hit heads 120 times. This number would be 120, not 2. All right, so my success chance was 0.5. So what are the chances I'm going to hit a tails? 50 or 0.5. And then my exponent says n minus x. N is number of trials. How many trials I have? 3. And then x is the number of times I want it to happen. 2. So in this case, it ends up being 0.5 to the first. But again, doesn't always happen like that. Let me show you a trick. Success, failure, these two numbers should always add up to what? 1. Always, always, always. And this exponent should always add up to what? The number of trials. So it's a good way of checking yourself. And then the bottom part is real easy. What does X stand for again? The number of times I want it to happen. Will you just grab his papers and put them on the counter for me? Thank you. So the number of times I want it to happen is going to be 2 factorial. And then it's n minus x, and that's in parentheses with the factorial on the outside. You're going to pull what you had up here down. So in this case, it's going to be 3 minus 2, so number of trials, minus how many times I want it to happen with the factorial on the outside. So this is what it looks like factorially. Oh, what's going on with this? And then this is what it looked like with it spelled out. And we get the same number that we got doing the probability tree. Now this is a really small example. But if you were flipping a coin 500 times, you wouldn't do a probability tree for that. I mean, that would be a little absurd.
You would run out of paper before you solved it.
You can get one of those like bulletin board papers and go down. That could be a wall theme next year. Think about it. You could all be like, yes. You could have like you could be like the stick and the other person could be the dot. You could all be numbers.
No.
It's perfect.
Are you gonna wear your wedding dress tomorrow for the
Somebody stole my wedding dress.
Like someone you know?
We owned a house and we had tenants in it, and the tenants stole it. I honestly think I'm gonna dress with the seniors because their theme is close to my heart, and I'm gonna wear a kilt.
Okay, it's not that good of you.
Moved up the Scottish.
But I appreciate the juniors giving an invitation, asking the teachers to dress up.
Yeah, the juniors.
No, the juniors.
You're invited to come down.
I actually really like their theme.
What is your name?
I think it's very original.
This is such a weak
All right, last thing, and then we can talk more about wall day. The law of large numbers, all that means is the more times that how many more trials you do, the more likely you're going to be closer to the theoretical probability. So if you flip a coin 10 times and you get 70% heads, you're really not close to what it should have been theoretically. But if you flip a coin 500 times, you're most likely going to be closer to a 50-50 shot. Cool?